Let's begin by reviewing how we convert between exponential equations and logarithmic equations. How do we go back and forth between the two representations? Well, let's review what a logarithmic expression or equation represents. When we see a logarithmic expression, we should remember that it represents an exponent. So here in general, we have log base a of x equal to y. This logarithmic expression represents an exponent. We could call that exponent y if we like. When working with a base of a, so let me rewrite this in exponential form. If we think of a as our base, that's what the a represents, and then we said that this expression represents an exponent, and we'll call that y equals x. So this is how we go back and forth between these two forms. So for part A, where you want to rewrite the equation log base 2 of 8 equal to 3, we want to rewrite that as an exponential equation. Well, here our base is 2. So we have 2 as our base, and then the exponent is 3. Keep in mind that logarithmic expression represents an exponent. Here the exponent is 3. And then that equals 8. And we can verify that it is in fact true that 2 raised to an exponent of 3 does equal 8. For part B, we have log base 4 of 16 equal to 2. So here our base is 4. Our exponent in this case is 2, and that equals 16. 4 squared is in fact 16. So that's how we would write that logarithmic equation as an exponential equation. For part C, we have log base a of k equal to j. Here, even though we're working with letters rather than numbers, our base in this case is a, our exponent is j, and that equals k. So that's how we would rewrite that expression using as an exponential equation. For number 2, we want to write each equation as an equivalent logarithmic equation. So now we're kind of going the other way. We're given an exponential equation, and we want to write it as a logarithmic equation. So if we can just remember these two expressions, these two general expressions, and how to go back and forth between the two. For part A, we have 10 cubed equal to 1,000. So here our base is 10, so we could write this as log base 10 of 1,000 equals our exponent, and our exponent is 3. Keep in mind that logarithmic expressions represent exponents. Now when we have a base of 10, this is referred to as a common logarithm, as you saw in our notes here. When we have a common logarithm, we can rewrite that or express that without the base 10. So we can rewrite this as log of 1,000 equal to 3. So when we don't specify or don't indicate a subscript there for our base, it is implied that it is 10, which is referred to as the common logarithm. For part B, we have e to the m equals b. So here our base is e, so we can write this as log base e of b equals our exponent m. So here's how we would represent the exponential equation as a logarithmic equation. Now when we have a base of e, that is referred to as the natural logarithm. And the way we express that is we can write that as ln for natural log of b equals m. So what we've done here is we've replaced the log with the subscript of e with ln. And that's how we express the natural logarithm with base e.